Today's webinar will be presented by Drew Laws of Selgen Company. Drew also serves as the president of ARM. Drew, you can take it away.
Okay, thank you, Adam. Appreciate the introduction, and thank you for the reminder of our antitrust statement. Hey, everybody, it's a pleasure to be with you this morning. I appreciate you taking time out of your day to log in and listen to our story. I'd like to take just a little bit of time this morning and share with you our robot story that we've kind of gone through here at Selgen as it relates to our finishing department. So let's have fun. We've had a bit of a challenge, and I think some of you can share in that frustration. There's a labor shortage that exists here in the States, in Wisconsin in particular, and we live in a pretty rural community of Lake Mills. So we've got this labor shortage, which is resulting in quite a bit of overtime. And as you know, and everyone has experienced, that overtime can lead to poor quality. It can lead to an increase in accidents. It can lead to an increase in turnover, which then magnifies this labor shortage problem. And these go kind of round and round. I didn't list these in any particular order. I'm not sure if there is a particular order, but we're struggling, as many people are. And it's particularly frustrating in our finishing department, more so than our rotational molding machine operators department. And so we've got this imbalance in our production where we're continuing to rotomold parts faster than we're finishing them. And then this cycle that I've illustrated here just kind of gets compounded, and it seems to be, in many days, it's just this spiral downhill. In 1 year, actually, if you kind of zoom in on that accidents circle, we actually had 8 accidents that were really similar to each other, and all 8 of them were in our finishing department. When we look at our accident rates, although running a rotomolding machine at first glance seems to be more dangerous, most of our accidents are happening in our finishing department, and our labor shortage is more prominent in our finishing department. Our finishing department thus needs more overtime, and then you insert yourself somewhere into this kind of vicious cycle. And this is a challenge that we've been facing, and as I've talked to other rotomolders in the industry, I took a small amount of comfort knowing that we weren't alone. So robots, obviously, the topic of the webinar today, was one way that we felt would be very appropriate to actually tackle all of these things. Have you ever heard the phrase, Andy Stanley is credited for saying, leaders who don't listen will eventually be surrounded by people who have nothing to say? The same is true for suppliers, salesmen, etc. And at Selgen, we embarked on a journey to find somebody who would help us make some robots, and they wouldn't listen. It was really frustrating. We would tell them what they wanted, and they would respond by rephrasing our needs with what they felt we wanted, and they were miles apart. We wanted something simple. We kept getting proposed something very complicated. We didn't have a lot of money to spend on the problem, and the proposals we were getting were always 2 and sometimes 3 times higher than we told them our budget was. And so we went through this exercise a number of times with different automation companies, different integrators, etc. We would ask for this, and they would quote that. And after this rigmarole a few times, we just decided to do it ourselves. We were kind of tired of not being heard and not being listened to when we would have these guys in. And so Selgen Company, as many of you may know, we've got a pretty extensive metals fabrication division. The company started as a metals division, a metals company 50 years ago. So we kind of tapped into our tool and die expertise and our fabrication expertise. We had a hole in our head count as far as somebody who could help do the programming. So we just hired from the automation industry and brought somebody on board to help kind of fill that gap. And we started just doing our own robots and started just listening to ourselves. And it's been a pretty great journey. So I'll go through a couple case studies with you. The first one, and some of you have heard this before, we make a lot of liners. In fact, this morning, I took a walk through our facility and just snapped a variety of photos of liners, rotomolded, rigid, black, simple liners that are coming off of our rotomolding machine. So here's a photo of a stack of liners. This is next to another machine that's got 3 or 4 stacks of liners, and all of these are in different stacks because they're either different sizes, different shapes, or need to be cut to different heights. This is another sitting off of another machine. Here's a fourth photo, and someday they all kind of get gathered into, we got a pretty big building, as you can tell, but we make a lot of liners, perhaps 100,000 of them a year. And again, those come at, those get finished at a variety of sizes, and this is where most of our accidents were happening. Something as simple and non-critical as a liner was really becoming a thorn in our side as it relates to safety and accidents. So robots helped. Here's a couple other photos of finished liners that are waiting in our finishing department to be shipped out today, and then we'll repopulate these shelves for tomorrow's shipments. So our first robot, some of you have seen this video, and those on the call here that have visited here have seen this. This is a higher speed video. I'll show it a couple times, but before I do, what you're seeing here is a modular fixture. Each one of the front, the 2 sides, and the back, those pneumatic cylinders are sitting on linear actuators. And so we can move those linear actuators in and out to get close to the liner size. And then the pneumatic cylinders finishes the job and self-centers the liner. Here, I'll show the video. And it does 2 things. It cuts a couple hand pockets, one on each side, and then it trims the liner to height. The operator brings it back in and out, engages the pneumatic cylinder, and the liner gets cut over and over and over. Liners do. So this one particular liner might get trimmed at 4 or 5 different heights. So we sell them to the customer all at the same price. And sometimes the trim stock is a little more than other times, and we just turn that trim stock back into liners, actually. So that one is a little bit more complicated, but you can see the liner the robot actually hovers above the part, so we're hanging the robots upside down, which allows us to use a smaller robot and still achieve a pretty decent reach. So here's another quick case study for you. We make a lot of dome top lids, like so many rotomolders do. And I just went out in the shop today and snapped a couple photos of lids that are molded, ready to be finished. And we have the same struggles here. We mold faster than we're finishing, and we do a ton of these things. So a couple different snapshots from our WIP inventory area, and these will all get finished. A lid will get snapped inside of them, and we will either sell them as individual dome tops or we sell them in combination with a receptacle. So this provided an opportunity for a slightly different configuration. In this case, once again, the robot itself is about 8 feet by 8 feet by 8 feet. It's not a big area. We're hanging the robot upside down, as you can clearly see in this cell. And the table itself actually rotates clockwise and counterclockwise. And so the operator will load and unload on the front while the robot is cutting on the backside. Let's see if I can show this a couple times. This is also at high speed. So it cuts the mouth open for the lid, and then it trims the top off. it rotates around, and the operator then gets the next one ready, and it just goes back and forth all day long. Show this a couple more times just to give you an idea. That table is not robotically controlled, so there's no automation there. The operator is manually rotating the robot 90 degrees, 180 degrees each time, and after it's indexed, then they tell the robot to go. So there isn't any logic between the table and the robot. We wanted to keep it simple. We have a variety of molds that we're using to make these dome tops. And one of the challenges, and I think it's, it needs to be said that one of the challenges that we've experienced as we've gone down this path is some things that never mattered before now matter a lot. The slight differences in our many molds that make these dome tops have never mattered before. Because we finished them manually, some of those differences never mattered, and or they could be easily and manually compensated for. As we've wanted to automate the trimming, where's my mouse? As we've wanted to automate the trimming, those slight differences of a 16th inch here, difference between molds, are becoming very, very apparent. And so we have to get a little bit smarter about how we mount, how we design the fixtures, and how we locate the part, and what our datum, our main reference is, so that some of those nuances from mold to mold kind of get filtered out. But that's been one of the challenges. When you're finishing manually, minor differences are easily compensated for. All right. So with those slight introductions, we still have a labor shortage. We're not going to be able to fix that. But what's happened with these robots is our overtime in those two cells, the liner trimming cell and our dome top trimming operations, have gone away. We don't use any overtime in those two areas. In fact, not only do we not use any overtime, but we've reduced the labor by a third. So what used to take a team of 3 people and sometimes even some overtime is now down to 1 person with no overtime in these departments. Quality is super consistent, as you can imagine. They're all the same from part to part. We have had 0 accidents since implementing this. Which has been great. We haven't had the same accidents with the saws and the routers, and as it relates to liners and the dome tops, no accidents, 0. And we've had reduced turnover because of all of it. And so again, I don't know what the proper order is in all of this, but we haven't solved this nationwide labor shortage, but we have compensated for it, and it's been pretty great. So we're currently using 2 robots in our finishing departments with plans for 4 more. And anybody here on the call is allowed to come see it. We're going to have this single file line of robots, and each robot will be positioned near a rotomolding machine or 2. And it gets a little bit more challenging as you implement more and more robots, because the low-hanging fruit will no longer exist. The liners was a very low-hanging fruit for us just because of the sheer volume, the safety concerns, as well as the number of variety that we have with our modular fixture. It really all came together quite nicely. The dome tops was another really low-hanging fruit, and we're working on 2 or 3 others right now that I would consider kind of maybe the low-hanging fruit. But as you continue down this path, you're going to get to the point where some things are going to be harder to justify on a robot if you're just looking at, maybe if you're just focusing on safety alone, or if you're just focusing on throughput. When you put it all together, though, it's a little easier to justify. So it became obvious to us that these robots would be of benefit to others, not just us. So if you remember from the first slide, you saw 3 letters AIT. That's Advanced Integration Technology. That is actually our automation division here at Celgent. It's a separate company, and we have now started marketing and selling these to other rotational molders as well, and blow molders actually. So I wanted to give you just a little sampling of some of the projects that we've worked on with customers recently. This is there's actually two robots in this photo that you're seeing now. There's the robot you're staring at right in the face, and then there's actually one in the distance. And that one in the distance is actually our lab robot that's not out in our production facility, and we actually use this for customer development. So this robot you're looking at now was developed for and has since shipped to another rotomolder here in the States, and I'll show you some videos. We actually unveiled, for the first time publicly, a robot at Rotopolymer's Congress meeting they just had in Cancun earlier this month. And so it was down there trimming parts in addition to other rotomolding machines that were live and rotomolding parts, and there were machines grinding parts. It was pretty awesome to see all of this legitimate production happening outdoors, but our robot was there trimming parts for everybody to see. So here's a video for you. We wanted to show, this one is not in high speed. This is actually fairly slowed down. So a customer sent us this part, and we designed and built a fixture to secure the part, and then we used the as trimmed part they supplied to confirm our program. And so we're going to actually walk around this while it's happening a little bit, so you can see our robot's actually following an existing cut path. There's no bit in the router. It's not actually doing any cutting. This was a video that we shared with the customer as we were progressing through the project. So this particular part used to take, I don't know, 15 to 20 minutes to trim manually, and this robot does it in 3. So let's just kind of watch this. You'll see it following. There's some rectangular cutouts. There are some circular cutouts. We always try to pick a bit that makes the most sense. So some of the holes drilled will use one side of the double-ended router, and other cutouts will use the other side depending on what bit is required. So the motor's spinning the same direction, so one bit will be a reverse flute and another bit will be a regular flute. That way we don't have to stop the router and spin it the other direction, although we could. I can't tell you the customer. They have, this particular customer has purchased 2 robots now. We were down there recently helping with fine-tuning of these programs. This particular fixture holds one part, but the part gets trimmed 3 different ways. Very advantageous for them. So sometimes when we'll drill a hole, if the bit is smaller than the hole, we'll cut the hole. In many cases, the hole is the same size as the bit, so all we have to do is plunge, and it cuts the hole. So the robots are all from Yaskawa, and our company AIT is a authorized distributor of the Yaskawa robot. So what we have is really a framework that's about 8 by 8 by 8 with a Yaskawa robot suspended from the middle and a control panel sitting off to the side. The programming is all done with a teaching pendant using an as trimmed part as the initial pattern. So we don't utilize any CAD CAM. We can, but we have consciously chose to pursue the least expensive path and the least complicated path for both us and our customers. I think this is the last cut it makes, is the top cut. There is a pressure sensitive pad at the front of the robot, which if stepped on will shut everything down. And then after it's done trimming the part, it goes back to a home position in the back corner. You can then unclamp the part, which is typically pneumatic, and put in a new part, walk away, and hit the go button, and it will trim for you while you're doing something else. What we don't advertise is a robot that will trim flash. That becomes very complicated, and we've chosen not to go down that path. What we have done, which is pretty advantageous, is AIT will often sell fixtures before they sell robots, and that's because we have a lab robot. So even at Celgin, we will buy a fixture first. AIT will design the fixture. We will give them a part, trimmed and untrimmed. That fixture comes with the program, and then we get to go see if we like it. And if we like it, then we would just in turn buy the robot that would go along with the fixture. And so that's actually been kind of our inroads to many other rotomolders, is to sell them the fixture first as, call it tuition if you want. They'll come and see the fixture running on our robot trimming their part. And typically what happens is they walk away having been converted to the idea of using robots to trim their parts. Here's another one. This was on our lab machine as well. The customer sent us the part. We designed and sold them a fixture. Here, I'll see if I can get this into play. And then we did the preliminary programming here. It cuts a couple side pockets for holding, as well as it cuts the back out. And after this one was shipped to our customer and we went down and helped do the install, the program was sped up to twice as fast as what you're seeing now. This particular customer installed the robot right next to the rotomolding machine, and the part comes out of the mold and directly onto the robot and gets trimmed by the machine, the rotomolding machine operator, instead of going to a finishing department now. So it trims this second hand pocket, and then it will go to its home position. And after it's in the home position, it will allow you to disconnect the air, remove the part, and put in a fresh one. Here's another part that we did for a customer, and this one was the same. We sold them the fixture first. You get a little glimpse of the air lever, but we sold them the fixture first, and they bought off on it and bought a robot. It's been nice though, simply because our experience is, you know, no different than anybody else can experience too. So we were our own guinea pig. Like I said, we've got 2 running all the time, 4 more in the queue, and in fact, our 3rd robot has now been developed and built and then subsequently sold to other rotomolders twice now. So someday we'll get it. So those are the 5 video clips. I wanted to show you 2 that we've had in-house and kind of explain the justification for doing it, and kind of give you a glimpse on what we've been able to do externally for other rotomolders. And but I did want to open up for questions, whether you've typed it in. I'll see if I can do my best to answer them. You're also welcome to reach out to me if you're curious to know a little bit more about how we're doing it here at Celgin. Maybe you've got robots as well, and you know, we could help each other. I'd be happy to pursue that too. So, Adam, does anybody have any questions, or they can raise their hand and give them some control?
Yes, there are. We've got a few questions coming in, and for those of you raising your hand, if you would type the question, that'd be great. If you're not able to, for some reason, I can try to call on you. But I've got 2 questions here to start. What type of safety system are you using to keep the operator out of the area when the robot is operating?
Yeah, good. We've used light curtains. The first robot that I showed you with the liners, maybe I can go to that slide one more time. I don't know if it shows it, but let me see how I can do this. Hang on, guys. See if I can go show this one more time to make sure it's there. Yeah, I don't think we can see it. This particular robot actually had light curtains, past tense. Sometimes the hand pockets that we were trimming, and or the top of the part would fly out of the liner and kept tripping the light curtains despite our attempts to fine-tune the light curtain adjustments. So what we've since done, we've removed the light curtains on this particular liner, on this particular robot, and we have created like I said, we've put a safety barrier down in front. It's a pressure mat. So if you were to step on it, the whole robot shuts down within an instant. So that's in one particular case. In all of them that we have sold to other rotational molders, not Celgin, there has been a same pressure switch. Let me show you another quick video again.
This one. Oh, there you go.
This robot is behind you can't actually access it. So you can see, and it's pretty wimpy, but we had just curtains initially, and 3 days ago we've replaced those curtains with kind of like expanded metal. It's not expanded metal. We have our own laser cutter here, and so we've laser cut and bent and powder coated our own safety fence that goes on the back, the right, and the left hand of the robot. And on the front, the turntable is such that you can't actually get past it. And so the front fixture is actually the barrier to the back fixture, very similar to the way that most robotic welders work. And so the two right sides, the back is a physical barrier bolted to the robot, and the front is either a pressure mat or, in this case, the turntable.
All right, Drew, we have a lot of questions coming in. The next one, if you have multiple parts, how quickly can you do jig changes?
Pretty quick, too. So what we've done is there's a 10-inch bolt center on the table. Let me see if I can go find this picture. I'll quit. These are good questions, by the way. I appreciate you asking them. Right here. So the plate on the bottom of this fixture has a 10-inch bolt center, similar to Motion Master, by the way. And it's kind of laid out in a map. All of the ones on the left are lettered, numbered. All the ones across the top are lettered. And so each hole has kind of an address. And that address, I think, is shown in this video. I won't play the video, but yeah, so that each hole has an address, and this one is actually bolted to D8 and a few others in the back. And so you literally take out the bolt, you pull off the fixture, and then you just have to put the next fixture in its home position using the bolt hole pattern, which is all part of the whole fixture design. And then you go select the program and hit go. So it's minutes to change out a fixture. Minutes.
All right, Drew, the next question. Is this able to be tied into conveying equipment?
Yeah, it can be tied into conveying equipment. We have had some customers will call us and ask for the moon, and we've told them to I mean, we can't be everything to everybody. We're trying to implement a very simple one, but yes, there are inputs and outputs on the robot itself from Yaskawa. So we don't even have PLCs attached to this thing. There's actually enough extra I/O on the robot controls itself that we've been able, like the pressure switch and some of these other pneumatic things, some of the things that we're using. You could totally tie this into conveying equipment. Yes, but I would need to know more specifics to be able to answer more specifically, but it could be indeed. Could it be tied into a conveying system that has parts being fed in and out of the conveyor? That would be a little bit more complicated, and then you start getting into we would probably have to have somebody help us do that. We wouldn't have that expertise in-house, but sure, it could be done.
Drew, do you have any experience with loading the trimming programs using RFID or barcodes? Also, how long does it take to change a trimming fixture?
So we've been asked that question before. We currently do not recognize a fixture with any barcodes. It can be done if you have a reader on your end of arm tooling. What happens then is there's now an interface. The robot has to start talking to the fixtures. Our approach up to this point has been to have this really smart robot hovering above a really stupid fixture, and the robot has no idea what part is there currently, and it has no idea if there is actually a part there. It will just go and trim the path that you tell it to when you hit the go button. And if there's a part there, it'll trim it. If there's no part there, it'll still trim it. If there's the wrong part there, it doesn't know that. And so the turntable, there is an opportunity to put different parts on either side of the turntable. The risk is that the operator would select the wrong program when the wrong fixture was, he might get confused. And so what we've chosen to do in our facility is to put the same fixture on both halves of the robot, so the operator, she can just sit there and hit go the entire time. And then when they change out the fixture, they change out both. And again, both fixtures the fixtures are very, within minutes, you unloosen a bolt, you lift the fixture off, you put the new one where it's supposed to go. Currently, we do not have barcode reading, scanning, which would then input to the robot and go find the appropriate program before you hit the go button. It can be done, but that is not the way we introduce this to customers. That's not the entry-level model. Go ahead.
Will furrows that define the area to be cut help establish the robot path, since there's no CAD programming as mentioned?
Say that one more time, please.
Will furrows that define the area to be cut help establish the robot path, since there's no CAD programming?
I need to apologize. I did not understand the second word. Will what?
Furrows, F-U-R-R-O-W-S. Why don't we move on to the next question? And Bob, if you don't mind explaining that question in the question box again, we will get back to it. Are there any quantity points that justify the cost of the robot unit?
I have actually tried to find some sweet spot, but what I'm finding is it's more of a quantity complexity relationship. So with a super complex part, you could justify a robot with maybe even hundreds of parts a year. With really, really simple parts, that justification goes up into the tens of thousands, I'm afraid. And so I wish I had a number for you, but it's oftentimes complexity is more of a driver than quantity. This particular photo that you're looking at now is purely quantity based because it's a super simple trim. This fixture we're building now is both complexity and volume. This one was totally complexity. Volumes are pretty low, complexity super high, and so they were able to justify it based on complexity and not quantity. Sorry, I don't have a better number for you, but it is a kind of a moving target.
Why is Flash not being pursued using the robots? The next question.
Tolerances. When we started down this path, that was always one of the rebuttals from the existing automation companies. And they would say, if you included vision cameras, we could not only pick up on any slight orientation differences, but we could pick up on any shrinkage variation and color variation, et cetera, seasonality, and auto compensate for all of that. But then the robot's prices start to double when you implement vision systems, because then you need CAD CAM, and it gets more complicated than most of the low-hanging fruit requires. And so we tried it at the beginning, but it became mold to mold variation, part to part variation, shift to shift, season to season. It can be done, and a lot of automation companies are doing it. It just it seems to be one of the frustrations in the industry is as soon as you go down that path, the price of the robot will double and sometimes triple. So what we've done is the person loading and unload does the trimming of the flash either immediately before or immediately after the robot does the trimming. So it's just not something we've chosen to tackle. Most robotics guys don't want to tackle something simple. It's not their specialty. The integrators, We are kind of the opposite. We just want to go after the simple low-hanging fruit, which, a lot of the rotomolded parts fall into that bucket.
And a follow-up to that, this is a question, but I wonder if it's a suggestion as well. What if a raised bead is used to trim the flash?
Yeah, that would work, especially if some parts you could trim the flash. We are working on one right now internally where the part is hidden, and if you were to trim the flash lightly or if you were to trim the flash pretty aggressively, it wouldn't ever matter. So we are going to base our program off the smallest possible version, and we are going to base our cut speeds and our bit RPM based off of the thickest possible cut. And we will start trimming this part. It's got a lot of flash, it's an older mold, and we're going to trim it as if it was cutting a hole. And we don't really care if it cuts a little bit into the part sometimes or if it's just barely skimming the flash other times. So I will say you could do it, but if you're looking at trimming a cooler where it's super aesthetic all of the time, I would hesitate. But you could. A raised bead's a good idea. You just got to understand that depending on any variation, it may trim a little bit deeper than you might be accustomed to.
All right, I've got a question here about the location of the robot. States, first, thank you for the presentation. It looks like the robots have been located on the top generally. And the question is, can we say it's more effective generally in your experience to apply the robot program or to make it easier for the operation of the robot? Can the robot location be changed for the product's geometry so it can be located on the floor?
Sure. Yeah, totally. What we've found, and the robots, the farther a robot reaches, the less accurate it becomes. And if you have a floor-mounted robot, you actually have to have enough reach to perhaps go up and over the part or over and around the part, and you really start to push the limits of the robot. But robots nowadays are pretty awesome, even at their most extended reach. And the farther out you go, you can't have a very heavy end-of-arm tooling, and ours is pretty light, so we're not even close to those limits either. So if you had a product and you were only trimming on the front face or maybe the front and the left, or you don't really need access to all of these areas, you could totally mount it on the floor and go that route for sure. But a lot of rotomolding machines, they have just a couple different sizes. We've kind of taken the same route. Our robot cell dimensions were very much in keeping with parts that would typically come off of a Ferry 220, or they now call it a 2600 or the 2.6 from Rotoline. So that's kind of the sweet spot as far as part size. But totally, yep, robots can be moved left, right, up and down, wall mounted or floor mounted. It would just become a custom robot instead of an off-the-shelf robot cell like what I've shown you today. Everything I've shown you today has been an identical robot cell, pretty much. But it can totally be moved. I lied. One of the robots, we had to make the robot cell a couple inches taller because of part size.
All right, the next question here. Can you use robots to apply spin fittings to tanks or parts?
Yeah, I haven't. I think I'm trying to think through that a little bit. That's a really great idea. Loading it is probably harder than applying it, so there might need to be a little pick and place routine that goes, or you could literally, the robot could actually come out and present itself to you, so you could snap in the spin weld fitting and then it would go disappear and do the spin weld, but it could totally be done. Yeah, it would just one of the end of arm tools, it's a double axle, it's a double spindle router, so one of those would just have to have the drive tool for the spin weld, but it definitely spins fast enough to do it, you bet.
Next question, how do you account for shrinkage of parts? Are parts kept in a controlled environment before trimming? When trimming immediately after molding, how do you control the size and the temperature of the part?
So most of the parts that you're seeing have very forgiving trimming requirements. The liner, the dome top, that kind of goes back to the question of when is this justifiable? The complexity. If you've got ridiculously tight tolerances, then you're going to have to be really careful about how you treat these parts before and after they're trimmed. The parts that are trimmed immediately off the machine, like I said, they're super forgiving trim tolerances, very wide. We make a part here that's so tight that our machinists do it, our tool and die journeymen do it on mills in our tool and die shop because the tolerances are so tight. I would never try to do that on the robot just because of that very reason. So it's really ideally suited for pretty forgiving trims, which is also kind of answers the question on why it's not the best candidate for trimming flash. So it's some of the parts that we do, we can't do them off of the machine. The dome top we don't do off the machine because it hasn't shrunk enough. We actually let it sit around for about 24 hours at minimum before we'll stick it in our machine, just because it won't fit in the fixtures. Yeah, it's an awesome question.
All right. Next, has a cutting tool ever broken off in cycle? And if it does, what will stop it?
So we have had a cutting tool break off and nothing stops it. It just breaks, and then the robot continues down its path, and then when it's done, it goes to the home position. So luckily, I mean, without a bit, it'll be very similar to the video that I'm looking at right now on my screen. Without a bit, it just hovers above the part. With a bit, as it moves from cut to cut, it's always dodging the part and the fixture. So if the cutter breaks off, it goes back to the home position as soon as it's done. If it's a violent break off, it'll actually trip the sensors in the motors of the robot install right then and there. And then there's an audible sound. You go over and reset it, put a bit in, and then you actually just start the part over. It goes back to the home position. You put the part back in after the bit's in. You hit go, and it goes and trims the part a second time, catching up to wherever it happened when it broke, unless that scrapped out the part. We've broken.
All right.
We've broken like one bit, 2 bits maybe in 18 months, whereas we used to break them all the time when we were trimming manually.
Next question, going back to the furrows question we had before, whether you ever use the furrows to guide the robot since there's not CAD programming. Furrows are recesses, like a small channel in the shape of the area to be cut out.
Okay, thanks for that. I call them trim guides, but furrow sounds way better. I'm going to start calling them furrows from now on. Yeah, that's exactly what we do. So you can use the trim guides, or we will carefully trim a part manually, and then we use the as trimmed part with the teaching pendant to define key points along the path, and then the robot will kind of generate its own program in between some key paths, and then we go in and manipulate the paths, the speeds or arcs or lines or whatever. But totally, yeah, the trim guides, what I'm now going to refer to as furrows. You can draw a pencil, with your crayons or whatever, and draw on the part, and you can use those. And we do use CAD files. We just don't have any CAD CAM, so we will use a 3D CAD model and help define via sketches, or like you said, trim guides or whatever. But yeah, that's exactly how we do it. We use a teaching pendant to do the programming.
All right, the last question that we have here, do you train robot programmers for your systems?
Yeah, so our robots, so our machine operators make more money than our finishing department, and which is part of the problem of the turnover and the shortage and all that kind of stuff. We have defined robot operators as machine operators. So our robot operators actually make more money than our finishers do. That kind of ticks off some of our finishers, but this is the way we're going. So that comes with, they're not trained to program. One of the robot operators we have now has expressed some interest. And so we might, but currently we have an automation engineer that does all of the fixture design and all of the programming and helps troubleshoot the issues. And the robot operators currently are just kicking butt and taking names with parts. Yaskawa does provide training for programming and maintenance. And anytime somebody buys a robot from Yaskawa through us, it comes with a class, and we don't need the class, so we pass that class on to the buyer. So if you were to purchase a robot from AIT, that purchase comes with one seat at a training class of your choosing at Yaskawa in Ohio or Michigan, I think. And so you get to go and learn the maintenance or learn basic programming or whatever.
Thank you, Drew. If folks want to get in touch with you directly, if they've got questions for you, or there looks like there's still a little bit of discussion, how should they do that?
Just drop me an email. I'll give you my email address. My first name is only 3 letters, DRU, and Seljan is the company I work for. So my email address is drew@seljan.com, SELJAN. Alternatively, you can call my cell phone, which is 920-728-LAWS, which is my last name. 920-728-LAWS.